In this lecture, you will learn about the structural organization of the components of the respiratory chain and the reactions takes place by the components of the respiratory chain. So, as the electron transport chain consists of the four components, they are made up of four complexes, and there are some mobile carriers that are also present between the complex 1, 2, and 3, and the other carriers between the complex 3 and complex 4. So, the components of the respiratory chain or the electron transport chain, it is made up of the four complexes, right? So, complex 1, complex 2, complex 3, and complex 4. Complex 1 is also known as NADH-reductase. Complex 2 is also known as succinate dehydrogenase. Complex 3 is also known as cytochrome reductase, and complex 4 is known as cytochrome oxidase. So one by one, we will study each complex in detail, that how the electrons are transported, that electron transport chain. In the electron transport chain, these complexes are present, are arranged in order by complex 1, complex 2, then complex 3, and complex 4. These complexes are arranged in order, and the electrons are transported in a series of reactions, right? So electrons always move from the negative redox potential towards the positive redox potential. So electrons will move from the complex 1 to the complex 3 and then to the complex 4. And the electrons will move from the complex 2 to complex 3 and then complex 4. And they are mobile carriers, coenzyme Q and cytochrome C. Now let's see for the complex 1 in detail, that how the structural organization of the complex 1 and how the electrons are transported from the complex 1. How this NADH get reduced, get oxidized by this complex 1. So complex 1 is also known as NADH reductase, as the name indicates, NADH reductase, right? So it means that this complex 1 is going to reduce by the NADH. So from where this NADH comes, NADH basically present in the oxidized form, NAD की form में present होता है, but in the body there are different oxidation processes, there are different metabolic processes. During these metabolic processes, the NAD gets reduced. In that oxidation processes, in metabolic processes that occur inside the cell, this NAD will get reduced in the reaction and will become NADH, and then NADH is carried to the electron transport chain for the transfer of electrons. So this NADH will transfer its electron to the complex 1. So that's why this complex 1 is known as NADH reductase. When this NADH will give its electrons to the complex 1, this NADH will be again oxidized into NAD. So NADH, this complex 1 is also known as NADH dehydrogenase, because it causes the dehydrogenation reaction, that this complex 1 will remove this hydrogen from the NADH and NADH will be again oxidized to NAD, and then NAD will be again available for the other oxidation for other metabolic processes. Then NAD will go to the other metabolic process, other oxidation processes, and will be ready for the further reduction, and it will go to the other oxidation processes and will reduce itself. Okay. The other name is ubiquinone oxidoreductase. So this complex 1 is also known as NADH, ubiquinone oxidoreductase, because this NADH will give its electrons, and that electrons will be carried by the ubiquinone, right? So that's why this NADH and ubiquinone is going to cause the oxidation reduction reaction. In this complex 1, this NADH and ubiquinone, these will cause the oxidation reduction reactions. So that's why this complex is also known as NADH ubiquinone oxidoreductase, because ubiquinone is going to reduce this NAD. When it will get oxidized to NAD, then this ubiquinone will be reduced into ubiquinol. So that's why the oxidation reduction reactions occurs between basically the two main components are the NADH and ubiquinone. So what is the structural organization of the complex 1? Complex 1 में क्या होता है? Complex 1 is basically, as it's a protein in nature, it's enzyme. So it is made up of 42 different polypeptide chains, right? So there are different 42 polypeptide chains, different 42 amino acids that combines together to peptide chains and make up the complex 1, right? So the complex 1 is composed of the flavin mononucleotide. So there is a flavin containing protein. Flavoprotein is present inside the complex 1. The main component of the structure of the complex 1 is the FMN. Okay, so FMN होगा flavin mononucleotide, and there will be the 6 iron sulfur centers, right? So this FMN and 6 sulfur iron centers, so what they will do, they will carry the electrons from this NADH, right? So electrons, they will transfer its electron to FMN that is present in the complex 1, and there will be the 6 iron sulfur centers. Okay, but through a series of reactions, that FMN will give its electron to the iron sulfur centers, their iron to the iron, and then it will be transported one by one to these centers. It will go through these centers. And how it looks like, complex 1 just looks like an L-shaped arm. It's an like an arm extending into the matrix. So its shapes is like an L shape, right? So what will do complex 1? In the complex 1, the NADH will transfer its electron to the complex 1 and will be oxidized to the NAD, right? Okay. So when the NAD gives its electron to the complex 1, then these electrons will be transported to the coenzyme Q, right? Coenzyme Q will take these electrons, will get reduced. So the NADH, it gives its electrons and hydrogen to the complex 1 and it gets oxidized to NAD. So whereas these electrons and hydrogen will go from the complex 1, there is a coenzyme Q. Coenzyme Q is a carrier. It will take the electrons and the hydrogen ion from the NADH and will get reduced to and will become reduced coenzyme Q, right? So coenzyme Q take the electrons and hydrogen ions from the complex 1 and it also takes the electrons from the complex 2, right? It takes up electrons from the complex 1 and the complex 2 and then they transfer them to the complex 3. Okay. And what is the mechanism for all these? Like during the transfer of the electrons, when the NADH gives its electrons and the hydrogen transfers to the complex 1, right? And from the complex 1, they are taken up by the coenzyme Q. During the transfer of electrons from the NADH to the coenzyme Q, what happens? That the protons, they also pump the protons. Okay, there the energy is liberated, the energy is utilized. So this energy is used to pump the protons from the intermembrane space. When it gives two electrons, the NADH, it gives two electrons and these two hydrogen ions to the complex 1. Then what will happen? These are two electrons when taken up by this coenzyme Q. And as a result, the energy is liberated. The energy is used to pump the protons from the matrix to the intermembrane space. And there, the hydrogen ions will be collected. The protons will be collected for the process of chemiosmosis, and that will be later used in the synthesis of the ATP. So the whole reaction for this complex 1 is that NADH, it will give us electrons, two electrons and two protons. Okay, two hydrogen ions will be transferred to the complex 1, and from the complex 1 it will be taken up by the coenzyme Q. Then the final result will be that NAD will get oxidized and this coenzyme Q will get reduced, right? So it will carry these two electrons to the complex 3. So what will be the whole mechanism? That this is the structure for the complex 1. ठीक है, complex 1 के structure में क्या होता है? There is flavin mononucleotide protein, flavoprotein present होता है, and there are 6 iron sulfur centers. So NADH, it will give the transfer of how the transfer of electron takes place. That the NADH will transfer its electron to the FMN, and the FMN will then, from the FMN, the electrons will be transported to the iron sulfur centers, and from the iron sulfur centers, it is taken up by the coenzyme Q, right? So how this specifically iron center is present? What is the significance of this iron center? That this iron exists in two forms. That it has a 3 plus charge and 2 plus charge. When it has the 3 plus charge, then it has the ability to accept the electrons. When it will get the electron, then it will be reduced to Fe 2 plus charge, right? So it accepts the electrons and then transfers the electrons. So what is the whole mechanism? Let's look the structure. That is the structure of the complex 1. As the complex 1 is the large complex, okay, it's L-shaped, embedded in the into the mitochondrial inner membrane, right? And the NADH, when it gives its electrons, it will transfer. NADH will transfer two electrons. Okay, two electrons to the complex 1. So the structural now you know the structural organization of the complex 1. that's composed of FMN and 6 iron sulfur centers, and there is N2 center, right? So like how the electrons will transfer through a series of reactions like NADH. It will give its electrons to the FMN, right? It will be taken by FMN, and FMN will also take up the hydrogen ion. It will be reduced into the FMNH2, right? So it will reduce into the FMNH2. Then FMNH2, it will transfer its electron to the iron sulfur center, and then from the iron sulfur center, it will give to the N2 center, and then from the N2, these two electrons then are carried up by the Q, coenzyme Q. Okay, ubiquinone will be reduced into the ubiquinol, right? It will take the electrons from this N2 center, and two protons will be taken up from the matrix. ठीक है, तो आपके पास क्या बन जाएगा QH2, and now this Q is get reduced. So this Q will detach from this complex 1, and it's a lipid soluble, and it is movable, so it will move inside the inner mitochondrial membrane, right? So it will move and will approach toward the complex 3, and it will transport its electron to the complex 3. So as a result of this transfer of electrons, when the electrons are transported from this N2 center to the coenzyme Q, then what will happen? That the energy used is used to pump the protons from the matrix to the intermembrane space. Okay? So 4 hydrogen ions will be pumped from the matrix to the intermembrane space, and it will be collected here and used for the chemiosmotic processes to drop the chemoosmosis, and to drop the proton gradient that will be later used for the purpose of the synthesis of ATP, right? So this is again that this is the structure of the complex 1 L-shaped structure. It is made up of 42, almost 40 to 42 amino acids, right, embedded in the inner mitochondrial membrane. So FMN, the electrons taken up NADH. So complex 1 is specific for the NADH. NADH will give its electron to this complex 1, right? So electrons will be taken up by the FMN, and it will pass through a 6 iron sulfur centers, right? And then these electrons will be taken up by the coenzyme Q, and coenzyme Q will be reduced to will become reduced coenzyme Q. That ubiquinone will be reduced to ubiquinol, and then it will transport its electron to the complex 3. As the electron transport chain is located inside the inner mitochondrial membrane, right? So this is the mitochondria. It has the outer membrane, inner mitochondrial membrane. The space between the outer mitochondrial membrane and inner mitochondrial membrane is intermembrane space. So the complex 1, right? So this is the coenzyme Q, right? So complex 1 is specific for NADH. NADH will give its transfer its electron to the complex 1, and if these electrons will be transported to the coenzyme Q, will be taken up by the coenzyme Q. And when the coenzyme Q takes these electrons as well, the protons are transported into the intermembranous space, right? So it's a proton pump. As the energy used for this, when the electrons will transfer to the coenzyme Q, then the protons will be transported to the intermembranous space. So this is the structure of the complex 1, that is composed of FMN and iron sulfur centers, right? So when the NADH gives its electron to the will be taken up by the 11 mononucleotide, will be reduced to FMNH2, and then FMNH2 transfers electron to the iron sulfur center. Okay, iron तो आपके पास 3 plus charge होता है, then it will accept the electrons will become 2 plus, and it will be transported and pass through the 6 iron sulfur centers, and finally will be taken up by the coenzyme Q. Okay, and this ubiquinone, when it takes up the electron and proton from the matrix, right, it will be reduced to the ubiquinone. Okay, it will take these two electrons and will move inside the mitochondrial membrane, right, and will take up these electrons to the complex 3.